Alright, and welcome back. In this video, we are going to be going through Chapter 9, Section 4, titled Arcs and Chords. By the end of this video, we should be able to apply theorems about the chords of a circle. So please have out your guided notes. Let's begin. So in circle A, chord XY cuts off two arcs, arc XY and arc XZY. Arc XY is the minor arc, and that's going to be the arc of the chord of XY. If minor arc XY is congruent to minor arc XZ, then X is going to be the midpoint of arc YXZ. So in the same circle, or in congruent circles, one of two things can happen. Congruent arcs have congruent chords, and congruent chords have congruent arcs, which leads us into example number 1. We're given a circle here, and we're given if the length of PS is equal to 12, and the length of TR is equal to 15, we are asked to find the length of QR. Well, the solution is going to be as follows. We would know the measure of minor arc PS is equal to the measure of minor arc PT plus the measure of minor arc TS. We can add 50 and 20 together, and that gives us 70. So the measure of minor arc QR is going to be equal to 70. So the arc of QR is congruent to the arc of PS, and thus the chord QR is going to be congruent to chord PS. So the length of QR is going to be equal to the length of PS, which is going to have a value of 12. With this in mind, please work on problems 1 through 4 on the guided notes and resume when you're ready to move forward. So a diameter that is perpendicular to a chord bisects the chord and its arc. So if segment AB is a diameter, and segment AB is perpendicular to segment CD, then segment AB bisects segment CD, and X and segment AB bisect arc CD at point B. So a diameter that's perpendicular to a chord bisects the chord and its arc. So AB is our diameter of the circle. It's going to bisect chord CD, and point B is going to be cutting arc CD in half as well, which leads us into example number 2. We're given a diagram in the middle of our screen, and we're also given in circle A, the length of SQ is going to be equal to 12, and the length of AT is going to be equal to 8. Our job is to find the length of PR, or the length of our diameter. So we know that ST is going to be equal to TQ, which is half of SQ. Since PR is a diameter, it's perpendicular to the chord. So half of 12 is going to give us 6. Now we can use that, and we can use it within the Pythagorean theorem. We're going to know that the length of SA squared, the hypotenuse coming up over here, squared is going to be equal to length of ST squared plus the length of AT squared. So 6 squared plus 8 squared. Thus, we're going to have a 6, 8, 10 right triangle. So the length of SA is going to be equal to 10. So since PR is a diameter, so PR is twice the length of a radius, because SA, or AS, is a radius of that circle A. So we double it, we do 10 times 2, and that gives us 20. With this in mind, please work on problems 5 through 8 on the guided notes, and resume when you're ready to move forward. And lastly, in the same circle, or in congruent circles, chords equally distant from the center, or centers, are congruent, and congruent chords are equally distant from the center, or the centers. So on our diagram on the right-hand side, if the length of OX is equal to the length of OY, then we're going to know that the segment AB is congruent to segment CD. Likewise, if we reverse that order, if the length of segment AB is congruent to segment CD, then the distance away of OX is going to be equal to the distance of OY, or the length of OX is going to be equal to the length of OY, which leads us into our last example. In the middle of your screen, you were given a diagram. On the left-hand side, it depicts that in circle O, the length of FL is going to be equal to 3. The length of GO is going to be equal to 5. The length of OP is going to be equal to 4. We are asked to find the length of HJ. So we know that L is going to be the midpoint of segment FG. So LG is going to be equal to 3. We have it cutting through, and it's going to be perpendicular to that chord of FG. In the right triangle, OLG, we would know that 5 squared is equal to 3 squared plus the length of OL squared. And we can solve that to get into 25 minus 9 is equal to 16. Thus, OL squared is 16. We take the square root and we get the length of OL is going to be 4. And we're almost there. Since we know that OP is equal to 4, we know that the length of OL is equal to the length of OP, and FG is going to be congruent to HJ. Thus, the length of HJ is equal to the length of FG, and that's the same thing as doubling the length of FL, which means that we get 6. With this in mind, please work on problems 9 through 14 on the guided notes. Keep up the great work. Keep making yourself proud. Let us know if you have any questions, and we'll talk to you soon.